This is the third video on section 7.8, triple integrals with cylindrical coordinates. And so the integral that's given to us is in terms of rectangular coordinates. So we have the integral 0 to 3, integral 0 to the square root of the quantity 9 minus x squared, the integral 0 to the square root of the quantity 9 minus x squared minus y squared. Our function is z squared dz, dy, dx. Remember, we integrate from the inside out. So let's look at what this region is. So we have the dx on the outside. So x ranges from 0 to 3. Y is in the middle. Y ranges from 0 to the square root of 9 minus x squared. Now if you look at y equals the square root of 9 minus x squared, that's the top half of the circle centered at 0, 0 of radius 3. So we have the top half of the circle centered at 0, 0 of radius 3, but x ranges from 0 to 3. That means we are looking at 1/4 of the circle centered at 0, 0 of radius 3. We're looking at the part that lives in the first quadrant. And then we have z going from here to, or from 0 to square root of 9 minus x squared minus y squared. And so when we set this up in terms of cylindrical coordinates, we're looking at the quarter of the circle. R goes from 0 to 3, theta goes from 0 to pi over 2. That is the region in the xy plane given in terms of polar coordinates. And then we convert our function and our limits of integration into cylindrical coordinates. And so we've already done this with the 0 to the 3 and the 0 to the pi over 2. But this right here, when we convert to cylindrical, this is 9 minus r squared. So 9 minus x squared minus y squared is 9 minus r squared. So we have 9 minus r squared under the square root. So we've converted this to cylindrical coordinates. We have our dz, and remember the r dr d theta. And so now we'll find antiderivatives. Find an antiderivative with respect to z. We have 1/3 z cubed. The z limits of integration are 0 and the square root of the quantity 9 minus r squared. Substitute this in for z, substitute 0 in for z, and subtract. This is what we have. Then we integrate with respect to r. Now, here we have 9 minus r squared, and then we have an r term. We could use a substitution if we wanted to, but hopefully we've done enough substitution problems from Calculus 2 that by now we can just, what I call, eyeball this. And so we just find an antiderivative. And okay, I cheated a little bit here, so I kind of calculated this ahead of time. But when we have 9 minus r squared, we know that our exponent is 5/2 because this exponent is 3/2. You raise the exponent by 1. That gives us the 5/2 here. So we're going to multiply this by 2/5. And then when we use the chain rule to differentiate this, we're going to end up multiplying by negative 2r. So then we multiply again by negative 1/2. That's where the negative 1/15 comes from. It comes from the 1/3 multiplied by 2/5 multiplied by negative 1/2. And so this is our antiderivative. The r limits of integration are 0 to 3. Substitute 3, which gives you 0. Substitute 0, and then subtract. So now we just have a constant term that we're integrating with respect to theta. So we just have 81/5 theta. Substitute pi over 2. Substitute 0. Subtract.